Yeah, this is the problem that we were discussing yesterday, and the problem that we wanted to solve is something related to plotting a discontinuous function. Okay, so while plotting a discontinuous function, the problem is that almost all computer software produce a graph of a continuous graph of a function as a curve, assuming that the graph is continuous, assuming that the function is continuous, because it plots certain sample points, xy coordinates, and connects the sample points using smooth curves. That's how plotting in a computer graphics software works. This matplotlib or plot function in Python is also not different from that. So even if we are plotting the if a particular function, what we usually do is we will choose some x values and corresponding y values we will compute, and xy points we mark on the plane, and after that we will connect those xy points. That's how we produce the graph of a function. These things will work smoothly provided that the function itself is continuous. But if the function is not continuous, the problem is that points which should not actually be connected, those points also will remain connected. That's the problem. So we have already seen the problem here. Okay, I will try to show the problem once again, the problem that we are facing once again. After that, we will try to discuss the solution of that problem. So here we are trying to discuss the greatest integer function. Greatest integer function, we know that. Is it not audible?
No, sir, it's audible. Very much audible.
Okay, I
Please.
think somebody has commented. Somebody has given a message saying that it's not audible. I think it's probably on your side. You can try to increase the sound. Here, the sound seems to be somewhat normal. Please try to increase the sound on your side. Okay. So the problem, as I told, is that the greatest integer function in the range 0 to 1, just before 1, 0 to 1 in the sense that 1 is open, 0 is closed. In that interval, the greatest integer function assumes the value 0. In the interval 1, 2, where left point is closed and right point is open, the function assumes the value 2. In the interval in the left closed, right open interval 2, 3, it assumes the value 2. It goes on like that. Therefore, the function actually should have look like steps where there is no in between connection. Okay, that's how the graph of the function should look like. Okay, here we have imported numerical Python and with the short name NP. Now we are creating a number of points in the range 0 to 3.1. 3.1 we are choosing because we want to include the point 3.1 also with a distance of 0.1. Okay, and after that we are computing the greatest integer function coordinates as np floor. In programming language, the greatest integer function is known as floor function. So the floor of x coordinates is calculated. Now pyplot, matplotlib pyplot is imported as plt, which is short name plt. Therefore, instead of using matplotlib dot pyplot dot plt or dot something, we can straight away use plt dot. Okay. Now, after that, let me just comment out this. After that, we will come back to this after explaining what exactly the problem is. Now, suppose that we are trying to plot the graph of the function using the plt.plot command. Plt.plot. Suppose we try to plot. So here we need to give the x coordinates as well as the y coordinate. X coordinates, y coordinates is in the greatest integer function. So it's here. What happened? PLT. Am I skipping PLT? Okay, PLT is appearing after that. Sorry. So PLT should be kept here. So here it is. Now PLT. What's the problem? Ask PLT. Okay, there is no problem. Now PLT show. This shows the graph of the function. Discontinuous. Where is that discontinuous appearing? Sorry. There are many things appearing below that. I should comment out even that. Let me comment out this. We comment out this also. Prime. Okay, you can see that the plot is appearing something like this. This should have been a discontinuous plot, but it is not like that. Okay, this should have been a discontinuous plot, but this is not entirely like that. Okay, now what the plan is essentially that the problem happens because so let us try to see the points first of all. Let us try to see the x coordinates as well as y coordinates. Print x coordinates X coordinates are these points, and the points are 0, 0.1, 0.2, 0.3, 0.5, 0.6, 0.9. Let us look at this point 0.9. So after 0.9, what happens? That's the question. So at 0.9, what happens is that the corresponding y coordinate is found. But what is a y coordinate? Let's try to even find that. Y coordinates is stored now in greatest integer coordinates. Oh, this is y coordinate, not x. So corresponding y coordinate, you can see that 0, 0, 0, and 0 like that. And when it becomes 1, suddenly the value becomes 1. Therefore, x coordinate corresponding to the y coordinate corresponding to 0.9 is 0, and the y coordinate corresponding to 1 is 1. Therefore, what happens is that the point 0, 0 is plotted on the plane corresponding to 0, sorry, not 0, 0, sorry, 0.90 is plotted in the plane corresponding to the value 0.9, the greatest integer function gives 0. So 0.90 is marked. Okay, 0.90, you can see that 0.90 is appearing somewhere here. If you are able to follow my mouse point cursor, you can see that 0.9 is just before this this 10, this 1.0 point. From 0.90, see that 0 is here. From this 0.90, what happens is now connection is made to 0.9. The x coordinate next is 1. Okay, the next x coordinate is 1. So 0.9 comma 0 is one coordinate, is connected to, I'll just type 0.9 comma 0. This is the first coordinate, is connected to which coordinate? 1 comma 1, or 1.0 comma 1.1. So that's the problem. So 0.90 is not supposed to be connected to 1.1, because 0.90 to 1.1, the greatest integer function is actually giving a break after 0.999 and etc. You cannot say exactly where it is, because there is no number called 0. There is the number, like the number called 0.999 and etc. is actually 1 itself. So you cannot exactly say that at exactly at what point that that breaking should have happened. So anyway, the thing is that you should not connect 0.90 to 1.1. Okay, but if 0.9 is the one x coordinate and 1 is the next x coordinate, naturally connection will be made. Whatever you do, the connection will be definitely made. So how do you solve this problem? So how do you solve this problem? To solve this problem, what we have to do is we have to insert an x coordinate after 0.9. We have to insert a y coordinate after 0 corresponding to 0.9 in such a way that the connection from 0.90 to that point, the newly inserted point, is not possible. But if it's a number, it's going to be definitely possible. Okay, what I'm trying to do is, I will show you. I'm going to insert something. So what should I insert? I'm going to insert some number. Okay, so essentially to x coordinate, this is x coordinates is the name. Yes, I'm going to insert. Yesterday itself we have tried that command. I will just show by inserting one point. So to x coordinate. See, what I'm doing here is I'm inserting. I'm actually trying to insert one point which is not actually a number to x coordinates, and I'm creating a new numerical Python array with the same name as x coordinates. Okay, so a new array is actually created. The old array we are not using. We are actually pushing one more point into the old array, old x coordinates array, old x coordinates list, and I am going to store the new extra point added array to this x coordinates, same variable name. So x coordinates, what is to be inserted and where is to be inserted. These two things we have to tell. So what is to, where is to be inserted? So this is 0, 0.1. So this is the first position, because index counting starts at 0. This is 2, this is 3, 4, 5, 6, 7, 8, 9. So at the 10th position, so at the 9th position, 0.9 is there. As the 10th number, I am going to insert something which is not a number. Which is not a number. Not a number. How do you give something which is not a number? So giving not a number, use this nan. Nan stands for not a number. So what happens now? Let us try to see x coordinates once again. Print. What is inserted? Sorry, I should mention the position also at the 10th position. Okay, what is this? Oh, some comment is okay. Oh, sorry, once again, np.insert. So what's happening here? What is the new x coordinates list? 0, 0.1, etc. 0.9. Now here is an n, nan. Nan means not a number. Same thing I should do, because otherwise, if I do not insert another thing extra to y coordinates, the problem is that the dimensions of this x array and y array will not be matching. So I should do exactly the same thing with the y coordinates also. Y coordinates is stored in this, exactly at the same position, exactly at the same position. Now printing y coordinates. So say that x coordinates there is an and. Where is that? Here it is. Y coordinates also there is an and. Okay, x coordinate there is an and y coordinate also there is an and. Now let us try to plot once again. Trying to plot this once again. The same command but with the new x coordinates and y coordinates. You can see that the connection from 0.90 to 1.0, 1.0 is now lost. Okay, the connection is now lost. This is what actually we want. But the thing is that we want to achieve this thing, the loss of connection at all the integer points. Okay, we want to find the loss of connection at all the integer points. So what should we do? So what are the points where we should do this insertion? At which points we should do that? So at the 10th point we should do, at the which point? 20th point. Is it the 20th point? So this is the 10th point. A 10th point is between 0.9 and 1. At the so if we insert, what will happen? If we insert that, the number will be given a push to the right, right? Okay. So because the 10 point, the position after the first insertion, the number of points will be incremented by 1. Okay, so this is actually the 0.1, 0.2, etc. up to 0.9. This is the index number 9, and 1.9 is actually the index number 19. But you are not going to insert at the index number 20, because in after the first insertion, the index number 20 will become index number 21. So let us try to do that once again. I will show you an easy way to do all these things instead of doing this one by one. So inserting at 11, sorry, not 11, 21, sorry, 21, 21. Trying once again. Say that two connections are now lost. Two unwanted connections are now lost. So, which is the next point? It should be 33, right? Sorry, 32. 32. Now all the three connections are lost. I hope that this much is clear to all of you. This is a very interesting problem. Here we are trying to avoid points of discontinuity by by inserting some dummy kind of point in between in such a way that they won't be connected. That's what essentially we are doing. So let me just update this with the Google document. Sorry, I have not created the Google document. Let me do that. Just 1 second. Let me create a new file. So the link is here. Oh, sorry, I think the link is not complete. Just 1 second. Yeah, here is the link. The second link, you please try. Okay, let me copy and paste it to the Google document. Done. So the code is there. The entire code is there. So please use the second link, not the first link. Second link. First link is not complete. It seems. Okay. Now the next thing that I wanted to say is that see this technique. The problem is that suppose that we have too many points of discontinuity. Suppose that we are trying to plot a graph where too many points are there, but they are all locatable. At the same time, the problem is that the number is large. The number of points of discontinuity is large, for example. Okay. So in such a case, manually marking all these points is going to be a little bit difficult. Of course, if the discontinuities are given in such a way that they are all uniformly distributed, you can of course use a for loop. But there is a much more efficient way of it by Python to solve this issue. To find out the points of discontinuity, it is not actually finding out the points of discontinuity. To find out essentially to measure the jump. I would like to say the measure the jump in the sense that the difference between y values, if the difference between consecutive y values are differing by some margin. Okay, if they are differing by some margin, we can probably assume this is not actually the mathematical definition of discontinuity. What I'm saying is a practical way to solve this issue. So, if the y values are differing, even if we are choosing the x coordinates to be too close to each other, if the y values are differing by some epsilon, by predefined epsilon, then in that case you can mark the point to be that particular x valued point to be a possible uh, point very close to discontinuity. Okay, very close to discontinuity. I do not want to say that that point exactly is going to be the point of discontinuity, because here we have zero point 0.9 was the point from where to 1 some issue was happening. But instead of that, the point of discontinuity is actually at 1, x equal to 1. So 0.1, 0.9 to 1, if you are measuring the y value, you can see that there is a difference of 1. Okay. So in the case of greatest integer function, because we know that in the case of greatest integer function, always the jump is 1. The jump is always 1. So in the case of greatest integer function, we can probably try to use the logic that if the consecutive y values are differing by at least 0.5, not 1, at least 0.1, 1 is also fine, at least 0.5, then insert a not a number at that particular point, or at a point just after that particular that point where the difference is happening. Okay, so in between 0.9 and 1, 0.9 and 1, we should insert one not a number argument, not a number quantity there. Okay, so to locate that thing without manually without manually counting the points to be 10, 11, 21, 32, etc., like that. So there is a method offered by Numeric Python which is known as where, a method called where. Okay, let us try to see that where first. After that, I will come back to this program. Okay, I will try to show you the usage of where. After that, we will try to use where in this particular program. Okay, let me start a new program for demonstrating the use of where, which is a very useful function for many purposes. Let me just use it first. Creating a new program. This is the 39th program where. So exactly in the same way, we need to import numeric Python. So okay, to use where, what we are essentially going to do is the where function, as the name suggests, it is actually trying to locate where something is happening. Okay, it is actually trying to locate where something is happening. That's what the usage of the where function is. Let us try to see the usage of where first. Okay, suppose that we create an array. A numeric Python array we have to create, not just array, numeric Python array. So numeric Python array is created using np array command, because np is actually array is actually the command, but it is in numeric Python, which is imported as np. So let us create a numeric Python array. A is equal to np array. Suppose what should we create? Np array. Maybe I can create something like suppose 1 to 10. Let me just create 1 to 10. Range 1 to 10 or 11. And let us see what this is. So saving it as np where. Printing a, we can say that a consists of 1 2 3 4. Remember that this is not actually a list, because if it were a list, the elements would have been separated by comma. It's not like that here. Now where comes into the picture. Where means, where simply means where, that's it. So b, np where. So suppose that we want to find out all the elements in a which are greater than 5. So simply uses a greater than 5. And let's try to see the result. The result is a greater than 5, 5, 6, 7, 8, 9. But what is meant by this 5, 6, 7, 8, 9? This is correct? Do you think that this is correct? A greater than 5. We wanted A to be the elements in A which are greater than 5. This is correct? Anyone? So 5 is included here, right? And 5, 6, 7, 8, 9, and 10 is not included. So what is this 5, 6, 7, 8, 9? So we have simply asked for where, not exactly the value, but where. So NP where says that A is greater than 5 at index 5. A is greater than 5 at index 6. A is greater than 5 at index 7. A is greater than 5 at index 8. A is greater than 5 at index 9. Right? This simply gives the location, not exactly the values, but location. Now, how do we print the values? If you want to print the values, simply use A of B. NumPy arrays are quite flexible. You can use like this. You don't have to input a single number there. You can input an array itself there. So the values are in R, A, 6, 7, 8, 9, 10. So this is how we have to use where. But one thing to remember here is that when you are using where, the it is given as an array. It is not given as exactly a location. It is not given as a list, but it's an array consisting of list. So this itself is a list. 5, 6, 7, 8, 9 is a list. Okay, 5, 6, 7, 8, 9 is actually a list. Remember that. Okay, now I will copy paste this example. So remember that we have one problem pending there. I will be coming back to that problem. I'm just updating the Google document with this. A is greater than 5, then how a 5 is included in the list? As I told, it is not actually the values shown there are not actually the values inside a, but this is the indices of elements which are greater than 5. Okay, so the index of 1 is 0, the index of 2 is 1, 3 index has index 2, 4 has index 4 has index equal to 3, 5 has index equal to 4. Okay, so the values from 6 onwards is included. 6 has index 5, so this is the index 5. Okay, if you want to just be sure about this thing, if you are not very convinced about this feature, minus 5 to 5 with a difference of 0.25. A greater than 5 instead of that, a greater than 0. Because the problem previously is maybe the result is confusing. A range, sorry, NP range. But this is too much, so maybe I should take it to be from minus 1 to 1. Are you seeing this? So here we are looking for values which are greater than 0. Okay. So what are the values here? Minus 1, minus 0.75, minus 0.5, minus 0.25, 0. Greater than 0 means 0.25, 0.5, 0.75. So this is 0, 1, 2, 3, 4, 5. Fifth element onwards it's greater than. So fifth element, sixth element, seventh element. Okay, that's the index. I hope that that's clear. Where actually gives the indices of elements where the condition is met. Indices of the elements where the condition is satisfied. Okay, not otherwise. It is not the values of the elements, but indices. Values if you want to print the values, then you should print here. It's already here. The values are here. A in square bracket you should give B. Then the value 0.25, 0.5, 0.75 will be printed. Okay, welcome. So this is how we have to make use of this NP where. Now I will give you one more example where NP in numerical Python where needs to be numerical Python where actually gives um, a better usage, an example where the usage of numerical Python where is better explained. So suppose that a is greater than 0, a or otherwise, just one second, let me just think of it. If a is greater than 0, a, I will try to find out one interesting example. So let me just take c to be equal to np, or even otherwise np dot uh, absolute value of, no, absolute value does not make much sense. Np, okay, let me just try once. A star, I'm just trying. C. A is less than 0, A, otherwise this. and print A of C. I'm just trying with something, or otherwise I will try to print C itself first. What is the result? What is the result of this? Can somebody explain? Can somebody find out the difference between B is equal to NP where A greater than 0 and C is equal to NP where A less than 0, A square? So this is the result. Any guess from anyone? What is exactly happening here? So A less than 0, A square. So you can see that A less than 0 is happening at which places? I will try to print A also. A is already here anyway. A is already here. A is minus 1, 0.75. We can see that minus 1, 0.75, 0.5, minus 0.25, up to 0 is exactly taken from A. After that, what happens is 0.25, 0.065 is given. 0.5, 0.25 is given. 0.75, 5625 is given. So what's happening at these three places? What's happening in fact at these four places? Here at these places, what's happening is here this where command, where function actually gives you at places where A is less than 0, it is giving exactly the values in A back. Okay, it's not giving indices. Instead of that, it's giving exactly A back. At places where A is not less than 0, which means greater than or equal to 0, it's giving A square, the square of values in it.
Like if else.
Yeah, if else, one good thing with this is that in the case of if else, you can apply if else only on one number at a time. But here, where is being applied to the array of elements? Exactly if else only, but it's being applied on an array of elements. And the interesting thing is that if you are running a large program, this particular technique is much more faster than using if else. Using where is much more fast because it's Python. In the case of if else, what happens is that we are unpacking the elements. That thing is inside one pack called array. From that, we have to unpack those elements, we have to process them, and we have to create another array. But here what's happening is that, so where is being applied completely entirely by Python technique, and inside that's happening using some efficient algorithm so that the program speed will be much more comparative. Okay. So NP where can be applied simultaneously into many. Okay. So that's the most interesting thing about NP where is, and in fact you can give here you can even give some other array also you can give. There is no problem. Some other array also you can give. For example, I'll give one more example. Angles suppose equal to, I'm giving in degrees NP array. Sorry. So for defining it as an NP array, what I should do is I can define it as a list and enclose inside NP array. So let me just give some angles. Let me just define. So 15, or otherwise I can just define it as a range. Range 0 to 361 with a gap of say 15. Printing angles. I get 0, 15, etc. Now, okay, that does not make much sense. The problem is, even otherwise, I can directly apply sine or cos to that. There is no problem. So the sign available in NP, the numerical Python actually supports pushing an array of values into that sign so that we can get sign of the entire values directly back. So this program that what I had in my mind is not going to give any newer ideas. So what I want to say essentially is that here instead of A at this place, this is the condition. Just like as already pointed out, this is the condition. Instead of A, here we can actually give a B array also. But B array, the problem is that the indices should match because if the indices are different, that may not work. Okay, the dimension of the array must be exactly the same. That we must take care of. Okay, so this I'm not proceeding with this example. So I think that's it. So this is all about using NP where for locating all the positions where something is happening. Okay, so let me update this in the Google document. Let me update this in the Google document. So from the beginning, I am copying and pasting. That please try. Okay, now trying to locate the discontinuity using this NP-where feature. That's what we wanted to see. Instead of manually giving points, okay, let me just save it. Instead of manually locating the points, let us try to locate the points using NP-where. So let me just copy and paste this to a new program so that we can start afresh. Handling discontinuities. Once again, the same problem, but the only difference is that we are going to find out discontinuities using NP-where. So the problem number 40, handling discontinuities using where. Saving it. Once again, we are importing. This is not equally spaced points. For spacing points equally, lin space should be used. But the problem here is that okay, here since we are creating equally spaced points, we don't exactly know that where this problem is happening, where this difficulty is going to, because in the case of previously we were using 0.1, 0.2, etc. like that. Therefore, we can count exactly where this discontinuity is happening. But here, since 100 points are being created, we need to now manually locate where exactly the discontinuities are. But we are not going to do that. We are going to make use of NPI. So up to here, everything is fine. No plotting. Maybe if you want to see the x coordinates, we can try to see that. X coordinates are all here. So yeah, one is anyway here. What about two? Two is also here. All the integer points are anyway here. So that's it. Okay, now we are going to define. We are going to use the technique is that suppose that the y values at 2 points, at two x values differ by more than an amount. We define that particular point to be a point of discontinuity, a position of discontinuity, or point of discontinuity. The position between the x values where y values are differing by a huge number, which we define. There we are going to insert nan. Okay, there we are going to insert nan. That's what our technique is. Okay, let us define the margin to be, or what should we call? Um, Let us define it to be epsilon because that's the symbol that we use for denoting small positive numbers. Okay, let us define epsilon to be equal to 0.5. Now let us locate. So what should we locate? Discontinuous positions. So how do we locate? So we need to take NP array np where what should we do? So what we have to locate now, what we have to check for now, the difference between. So for that we need to use the for finding the difference between consecutive points in, for finding the difference between consecutive points in an array, np array, we can use the np diff function. Okay, so np diff. So difference in what? Greatest integer coordinates. It's already arranged in the increasing order because already x coordinates are in the increasing order. Greatest integer function is an increasing function of x. So np difference when it is more than epsilon. So we need to locate the points where the difference is more than epsilon. That's it. We are only trying to locate the indices where this problem is happening.
So here we should not give that x coordinate, the NP difference between the greatest integer coordinate minus that x coordinate.
Uh, what you want to say is that x coordinate also. See here we are actually locating. Previously we noticed that the problem is happening at index number 10. Problem is happening at not index number 10. Problem is happening between 9 and 10. Problem is happening between 19 and 20. Right. So here the discontinuous positions will be only giving those indices. And in x coordinates as well as in y coordinates at those positions we will be inserting 9.
Okay.
So we can see this. See, let us see.
So, sir, we are finding the difference between the two array. So I think that
Not, no,
x
no, no,
coordinate
not
should be
two array.
given.
Not two array. We are finding the difference between consecutive elements only in greatest integer coordinates.
Okay, okay, okay,
Because
okay.
at 0.9, at 0.9
Right.
to 1, the difference is 1.
Exactly.
Yeah, that's it.
Okay.
Difference is greater than epsilon. That's it. Difference in the y values is greater than. See, whenever we are
Okay. So
trying,
it is
yeah,
consecutive difference between the two elements.
Exactly. See, how do we define the discontinuity in case of a real valued function? We are actually checking whether fx and fy differ by epsilon. We can find some delta in such a way that fx minus fy is less than epsilon, provided that x and y are differing by that delta, right? Exactly the same thing. We are doing exactly the same thing. We are trying to find the difference between y values if it's greater than some number. We are going to say that particular point is a point of discontinuity. That's it.
Okay. So here NP difference basically find out the consecutive difference between the two points.
Exactly.
Okay. Okay.
Exactly. So we can see that. I'm going to print that. So discontinuous positions are, I'm just going to print that. It's here. You can see that it's at, what is the value I have given? 32, 65 and 98 because we have taken too many points. Okay, let us try to reduce the points. So discontinuous points are 6, 12 and 18. We can see that if we are going from 0 to h3, 0 to h3, we will be getting 1 point at 1, other at 2, other at 3. Okay. So here you have a gem. Here you have a gem. At here you have a gem. This is not 2, but 2.05, etc. Here you have a gem, and here you have a gem. Okay, these are the positions. And if you want to print out the positions also, print out the x values also correspondingly. Print x coordinates. You can even do that. See this. This is the x coordinate where the problem is. From here, the problem is happening. From here, there is a problem. 1.89. Where is that? From 1.89, it's going to 2. There is a problem. 2.84, 2.84 to 3, there is a problem. Okay, this is what we are trying to find out. So now there is one more thing. The discontinuous positions is given to be an array. Okay, so we need a list, not an array. We need actually a list. So we need to take out, we need to, just 1 second. x coordinates where discontinuity starts. So at the position 6, 12, and 18, see, we actually want only this much. This array, all these things are not really necessary for us. But the numerical Python where will be returning the value just like this. So to take out this particular, see, this is actually an array inside an array. Okay, this array is actually inside an array. To break this array bracket, we use 0 here because 0, this is the first element in that array. Okay, let us try to see what exactly is coming out. But this will not work. This also may work, I don't know. Just see that. Oh, this is also working. So now the discontinuous positions are given to be 6, 12, and 18. Okay, the extra array, the word array is not really necessary for us. So so for that we are using the index 0 because the discontinuous positions given by NP where is actually a list of arrays or array of lists. So in from that we need to check, we need to find out only one. We need to find out only one. Okay, if you remember the previous problem, you might have seen here that if you are printing, suppose that you are printing here, NP where is that NP where? Here, if you are using this program, here you are actually getting NP where this is a less than 0, a otherwise greater than 2. Okay, if a less than 0, suppose that we are simply taking a here. No, no, this is not like that. So, sorry, what I said is not correct. So, here the problem is that if you are using NP-where without any value being specified, what happens is that this is returned as an array inside an array. So, let us try to see the type of this, then we can probably understand it more. Removing this 0, I am trying to explain why this in square bracket 0 is being used here. So this is a tuple. Which is a tuple? Discontinuous positions is a tuple. But inside this tuple, you can say that this is not a tuple. This is a tuple of arrays. So from that, we are trying to take the first array. This is a tuple of arrays. See, you can see that there is a comma afterwards. That means that it's continuing if there can be more elements. But in this case, there is no more elements. Only this much is there. So if you take this to be 0, now this actually became an NP numpy n-dimensional array. So we want only that. Tuple of arrays is not required here. It's not necessary here. Now one more problem is there. Discontinuous positions are 6, 12, and 18. Okay. But what is 6? Where is the 6? 0, 1, 2, 3, 4, 5, 6. So if you are inserting something at the 6th position, then it will be inserted at the position of 0.94, pushing 0.94 to the right. If you insert something at the 6th position, 0.94 will be pushed to the right, and that number will be inserted, that number or NAN will be inserted at the position of 0.9, which is the 6th position. But we don't actually want that. We actually want it to be inserted at 1.10, etc., and 1.10 should be pushed to the right. So we want the index to be one more. I hope that I'm clear in that. Otherwise, the problem is that between 0.78947368 and 0.947368 NAN will be inserted. But that is not actually we want. We want NAN to be inserted between 0.94 and 1.10. So the insertion position is not actually 6, it is 6 plus 1, which is, we should add 1 to it. That's all. So the positions now become 7, 13, and 19. 7, 13, and 19. Now insertion, the final step. X coordinates, we are going to insert np dot insert. What to insert? Where to insert? To insert to x coordinates. At which position to insert? All the positions mentioned in the discontinuous positions. It's one stretch we can do that. What to insert? NA. Let's see this. Oh, sorry. np.na. We can say that between 94 1.10 NAN is appearing. Between 1.89 2.0 NAN is appearing. 2.84 3 NAN is appearing. Fine. Perfect. Now the same procedure for this also. Exactly the same position. There is no difference. Now plotting. Plot x coordinates, y coordinates, and show. Sorry. PLT show. The graph is here. And now we can increase from 3 to 20 or whatever. Oh, only 20 points because no points are there now. Because all the India points are taken. So you need to be careful. So 100. See this? I'm updating the Google document. I'm pasting it as a new file, as a new program. Update. Okay, I hope that this problem is somewhat interesting to all of you because this actually tells you that even though we are trying to understand how to make use of a programming language to help us in doing mathematics, this example actually tells you that the brain of a mathematician or mathematics student is much more better compared to that of a plotting software because plotting software it will not apply anything extra other than whatever is set to it for plotting. But if we are trying to plot, we have with our experience, the way in which we can identify the points where there can be some problem. We will not attempt to plot like this. So we can use plotting software, computer software for finding out, for getting more and more insights into mathematics problems, research problems. But you need to be really careful. Don't trust uh, the programming language like, as the saying goes, like a gospel. Don't be so religious about the output given by a programming language. You need to swallow that with a pinch of salt. Really be careful. And of course, the way in which we try to define the discontinuity. I don't really know that whether it's going to work in all the cases where we can find out the discontinuity. There can be some point where the discontinuity is really narrow, and software may not be able to do anything. Okay, there can be such examples. Okay, anyway. So I will try to. I will actually suggest you to try the problem of locating, drawing the graph of tan of x. Okay, tan of x, as you know, that if you're trying to plot that, there are certain points where problems can appear. So I'm not going to discuss that thing because the discussion about tan of x is also going to be exactly the same. So there is not much to discuss related to that. Now, if you want to increase the size of, increase the line color, all such parameters can be modified as in the case of previous problems. Like blue, square, if we give what will happen, you can see step-like effects. Okay. Now, as promised yesterday, we will try to define a function in our own and try to plot, because yesterday we have day before yesterday, I think yesterday, we tried to define a function using the symbolic Python, and the problem was that the function you define using symbolic Python cannot accept a list of values or numeric Python values. Now we are trying to see how to define a function and how to apply numerical Python functions straight away into that, so that piecewise definitions are possible. That's what essentially we want. Piecewise definition of a function, plotting of piecewise functions. So, starting a new program, 41. So, piecewise functions actually constitutes a large class of discontinuous functions, because we will be having discontinuity at where the pieces are actually trying to meet, or pieces are very close to each other. So, trying to define a function. The good thing about the numerical Python is that in the case of numeric Python, there is a function called piecewise, a function itself called piecewise. A function itself called piecewise is there. For example, suppose that we define the Dirichlet function. Dirichlet function is nothing but if it's okay. Dirichlet function is rational, irrational. We cannot do that. Rational defining is not very easy. Not Dirichlet function. What I wanted is a sine function. So if it's less than or equal to 0, if it's less than or equal to 0, I don't exactly remember the definition of sine function. But what I think is that if it is less than 0, it's given to be equal to -1. If it's greater than or equal to 0, it's given to be equal to 1. SGN, sine function, I mean SGN function. Signum function, I think that's what, or sinum function usually called. So let us try to define that function and see how to use that for plotting something in Python. So defining SGN. So SGN function can be straight away defined using okay, SGN of x. What should we return? So we are going to return even that's not really necessary. We can define straight away SGN to be even this is not required, SGN, that's it. So okay, that's not actually making okay. I'm not very sure what exactly I'm trying to do with this. Okay, let me define, and after that I'll try to see if there are any problems. I will try to solve that. SGN of x. So the definition is that SGN of. So the problem here is basically that SGN of x. Okay, return. So for that I need to import numpy as np, the usual thing. Return np piecewise. So there is a function called piecewise. So what we are going to return is, suppose that the SCM function, we know that if we need to return x if x is less than 0. Oh, sorry. We need to return -1 if x is less than 0. This is correct. -1 if x is less than 0. No, this is a function of piecewise, it's a function of x. If x less than 0, so we are putting the conditions here, two conditions, x greater than or equal to 0. It's a function of x, piecewise function of x. And what are the values? We return -1 and 1. Let me try to see that. Let me try to define x to be as an array of numbers, or a range, say -1 to 1 with a gap of 0.1, and print SGN of x. Saving, printing, x also can be clear. This is correct. Maybe to understand it clearly, let us take the distance to be uh, 2. So -1, -8 into 10 raised to -1, which is essentially 0. -0.8, 0.6, etc. So how many negative values? 1, 2, 3, 4, 5, 6 negative values. This is actually 0. 6 negative values. And this is not 0. This is very close to 0. That's it. 6 negative values. No, this is 0 almost. This is 0.2. So 1, 2, 3, 4, 5, 6 negative values. So 6 minus 1 is expected. -1, 2, 3, 4, 5, 6. Right? So the structure is that it's a function of x. We are deciding something based on x. These are the conditions, list of conditions. If x is less than 0, return -1. If x is greater than 0, the value is +1. Return it as again as an NP array. So we can even plot it. Let me define one more. I think yesterday we tried to define a function but failed. Let me call it as f, or f of x. So what we are trying to do is we are trying to, in case we are from -1 to or minus pi to 0, we want the function to be equal to sine of x, or even x square is fine. Suppose that -1 to 0, it's x square. From 0 onwards, it is x. Okay, that's what I want to define. -1 to 0, it is x square, and 0 onwards, it's x. So -1 and 0 onwards. So here we need something specific, something known as a lambda constructor or lambda function we need to make use of. So since we are not actually returning an exact value, but instead of that, we are going to trying to return something again in x. Okay. Here we cannot simply put this is not correct. If you are putting np sine, not np sine, sorry, x square we want, right? X square or x. If you do like this, it will not work. Let's try to see that. F of x say this. This is not correct. So instead of that, here you have to use something called a lambda, a special function. So lambda of x corresponds to x square. So you are returning x square. Now corresponding to x. Try. Now plotting f of x. Import matplotlib. I plot as plt, Python plotting as plt plot, what to plot, x and f of x. Plt show. Hey, why is it happening like this? Why x square is looking like this? I think I am taking too less number of values here. I should take 0.01 or even 0.001. No, why? What's the problem here? Oh, if x is less than -1, there is no less than -1. X is less than 0, I should have used. Sorry, x is less than 0, that's wrong. Maybe I can take it from 2 to 2. Or even 2 to 4. You can see that from -2 to 0, it's a curve. It's x square curve. Okay, from 0 onwards, it's equal to x. So here you can apply the sine curve also if you prefer. So np dot sine. This is how we define a piecewise function and use it in numerical Python, plotting and other kind of stuff. Let me update the Google document with this. So if you are trying,
So, sir,
yeah, please.
sir, is that can you say that piecewise this function is it a means general case of where function np where
Which function?
that np piecewise
Yeah.
is it a generalized function of np where?
I don't exactly know, but we cannot say that it's a generalized version because NP-where I think it's much more powerful than piecewise itself, right? Because NP-where can in fact give you the indices, but piecewise is actually returning only the values, not indices. Okay, I think they have entirely two different purposes.
NP where also in the second case like if else
Yes,
it was
yes,
returned
yes, yes,
as
yes. That's correct. That's correct. NP piecewise also can be. I think you can write an equivalent statement using even NP where. Okay, let us try to see that. So if you want to use NP where, how do you use that? Return NP where. What should you return from where you are returning? You need to put a condition here. But here you can put in the case of NP where you can put only one condition, right? NP where you are putting only one condition, but here you are putting multiple conditions and multiple returns are possible, multiple subdivisions are possible here.
Okay. So that's why it piecewise might be the generalized case of NP where.
No, that's what I'm saying. Piecewise, I don't know whether it will give the indices or not. See, suppose that in the case of the previous problem, we wanted to find out the positions. Okay, indices.
Right. Then it will cannot be.
Yeah, there we cannot use that. Okay, that's a very good question, but it seems that they are different. They have different purposes.
So in this problem, like we have two conditions inside this NP piecewise.
Yeah.
So I think that NP where we can apply like NP where x less than 0 and at one for lambda and other.
Do you want to? Do you? Are you saying that we can put something like inside the square bracket we can give two conditions?
Yes, sir. It is like the same condition. Like if that x less than 0, and
Okay,
we
let me
take that.
let us just try to do that here itself and see if it's working. Okay, so this is what essentially you are trying, right?
And this is less than 0.
We have an error.
So the first condition that if in the place of x, if we write just x less than 0 and remove this particular the condition within the square bracket. Yes.
So
And,
you want to say that x less than 0, you want to return this,
yes,
and if x less than, greater than 0, you want to return this.
right.
This is what you are trying to do, right?
Yes, sir.
Okay, let us try to see the f of x value. Maybe here instead of lambda, I think in the case of where this lambda is not necessary,
All right.
we have not used lambda there. Let's try to see that. Okay, in the case of 2, it's working.
Please, okay.
But what about more than 2? So how do you specify more than 2 and the return values? Because where is accepting only 2 as the return values. Here only 2 are accepted. But in the case of lambda, you have a list. Okay, let us try to see if more than 2 can be, we can try. There is no harm in that. NP where suppose that we have multiple conditions x less than 0, x less than x greater than 0, and okay x less than 2 and x greater than 2. Suppose we keep 3 conditions simultaneously, and return value suppose x square sin x and say 1, just trying with 1, trying. That's a problem. So NP where is expecting a condition where this could be said to be true or false, not multiple things. So only 2 conditions are accepted in where. So either it is this. So NP where can return values depending on either the condition is true or the condition is false. There is nothing more than that. But in the case of piecewise, it's not like that. Piecewise, there are multiple conditions are possible. X less than 0, x greater than 0. Maybe we can try with something more also. Let's try. X less than 0, x greater than 0, x less than 0, x greater than 0, and x less than 1, x greater than or equal to 1. I am putting 3 conditions here. And here, instead of any value, I am just giving 1. Trying once again. Okay, I think I need to use and we try. not very sure about this. I'm trying.
Okay.
Is it working? Do you think it's working?
Yes, I think.
Maybe which is the range we have given? We don't have anything in this range. Right? Okay, where is that? Okay, -2 to 5, right? After 5, we are getting only 1, and up to 1, what we are supposed to get? X less than 1, x greater than 0, what we are supposed to get? Up to x less than 1, it is sin x, right? So 7.8
Fine.
into etc. e raised to -1 is zero point 0.7 approximately. 0.78. I think we are getting it here. Okay, let us just same condition. Let us try to put if we have not used the bracket properly. Let us try with where same way. Still we have an error here. I think where is not working the way. It cannot accept more than one. It seems. Okay, maybe let me try to delete one and see. No, where multiple conditions are not allowed. What about this? Greater than 0, either x or y. Oh, sorry. Here you need to give x also. I think that's okay. Okay. A mistake is there. Just 1 second. So x was not given. Where should I give x? I should give x here. This is exactly the same. In the same way we are imitating. Okay, but it doesn't seem to work. This seems to be wrong. This seems to be correct. So multiple conditions, multiple logical conditions, multiple pieces can be made only using piecewise it seems. Okay. So the piecewise function can be used for this purposes. Okay, this is the second thing that we wanted to discuss yesterday, but could not complete piecewise function. Now, the third thing that we wanted to discuss yesterday was something related to changing the position of labels in the case of a graph, right? Here we have instead of axis we have a frame here. Okay, instead of axis we have a frame, and on that we have some axis. I'm starting a new uh, program. I think this is already running. Okay, let me update all these things in the Google Sheet first. So I have updated the Google Sheet with all these piecewise definitions. You can try that. Piecewise is one of the most beautiful functions available in numerical Python, I believe, because most of the times we will be faced with handling discontinuous, sometimes um, having discontinuities but integrable, such kinds of functions. But in the case of such functions, defining the functions, plotting the functions, handling the functions, all these things are really difficult. But numeric Python piecewise, numeric Python where these two functions are really handy in these such situations. Okay, try to get control over these. Now starting a new program for dealing with access. So once again, import matplotlib. Okay, the program name is 42 more on plot. Import matplotlib pyplot as plt. So this is a kind of a standard statement in most of the Python programs where plotting is intended. Import matplotlib pyplot as plt. So if you copy and paste this command in Google, you will be finding many programs with this line included in the program. Just 1 second. So let me just try to turn off the access. I'm just trying to find out one quick way. There are different solutions, but I'm finding that which one is much more easier to understand. That's what I'm thinking. Okay, but the technique being suggested is actually removing all the spines pose set visible. The taxes we want. Okay, let me just try to show that method, but I don't know whether that is not exactly the same thing that we wanted. First of all, the axis label. Okay, changing the position of the axis label. So if you want to simply change the axis label position to something like what do you call? So if you have axis, but you need subplots essentially, not plot. It's PLT. Okay. Just 1 second. I just see. But, so essentially, what we are trying to do is to. Okay, let me try. I have just imported. I'm trying to show x is equal to. No, numerical Python is not imported. Import numpy as np. Now x is equal to creating some points. Linear space. Let us plot the sine graph itself. np dot lim space from -2 star minus np dot pi to 2 star inp dot pi, and say 100 points are to be created. So the x values are here. The y values are correspondingly sine of x, np sine of x. So if you, oh, sorry, if you plot, what happens is plt dot plot x comma y and plt show okay, np dot sine. What happened here? np linear space -2, oh sorry, -2. Okay, so the frame is appearing here like this. Now let me just try to adjust the position of this what you call the labels. Okay, we try to adjust the position of the labels. X labels and Y labels are appearing here. You can see that. Oh, X label is not appearing here. Okay, let us turn on X labels and Y labels. PLT X X label. What is the command? I forgot. I think X label. Anyway, let us try that. PLT. I think X underscore label is something that we should use. No, X label itself is okay, and PLT Y label also can be. See what it is. Sine wave Y, capital X, capital Y, Y label, X label, both these things are here. Now, for adjusting the label, for changing the position of the Y label, we are going to set the Y coordinates, Y axis label coordinates, and the X axis label coordinates. Okay, for that, let us create. So, I'm just trying to see once again. Okay, there is only one method being given. Okay, anyway, I don't exactly understand that why subplot is where subplot is coming into the picture. Anyway, I'm trying to use that exactly. I'm not understanding exactly that why this is being happening. So plt dot subplots. So somehow this should be kept before, even before the plotting happens. Even before the plotting happens, let's just put it to be here. And after that, let me just try to change the position of the x coordinates like this. Axis, setting the y x label. So the x label I am keeping to be equal to x itself. But now at the location equal to right. Let me try to see whether it's working the way in which it's expected. X label I set to be x. Set x label. Maybe I should not use even this. Okay, access set x label is already here. Access. Oh, only for so the access class, access basis, property x label, access. Let me just see once again how to use that. Access. It's new access object box figure. bounding box and closing axis is in box. Let me see what the documentation says. 1 second. Axis plot PLT box equal to false. Okay. On the other hand, let me just try with another technique. This doesn't seem to actually work. So instead of that, I'm just removing that. So remove this. PLT. I think I need to use something called figure. Axis figure. Remove the edges. So let me just so that's figure instead. I'm wondering why it's not happening exactly in the same way. Axis is equal to df plot. Axis is already in plot. Axis spine. No, it has no effect. Axis spines right is set visible is false, but still, okay. I think I should plot only afterwards, not before that. Let me just try once. Oh, but even this is not removing it. PLT plot, PLT X label. No, X label is not required. Y label is not required. But frame is still appearing. Axis subplots. That's correct. So axis spines. Right is now tend to be false. Plotting. Okay, now the right box is gone. Okay, the right is gone. But what about? Uh, okay, let me just remove the top and bottom also. Top, bottom, false. Okay, left. Okay, if I just keep these two, top not required, right not required, bottom required, left required. Let us keep that. Bottom required, right required. Let us keep that. So now this has actually become a graph like it is not a box anymore. Now let us keep the labels. So X label, I wanted to move it to right. Okay, I wanted to move it to entirely to the right. 1 second. Set X label. Trying once again. Access label. So X label is working fine. But why this plot text label font size is okay, but location label size, size, title size, legend, X large, access label size. But this by plotting X label is not actually giving exactly the location of that. I need to use access subplot X label, font size, access X label, set size. This doesn't seem to work somehow. PLT subplot X label. How am I using and subplots? Yes, I'm using set X label, set Y label. Okay, let me try once again. X label is set X label is already here. X label is set also, but the location is given to be right. Maybe I can give it in this way. The location is not changing. What's the error message I'm getting here? Text object has no property location. Okay, let me just try to find out what exactly it is. Why it is like this. OP. Okay, but font, let me try to do this once again. Equal to bold. Is it working at least? Okay, that's working. Font weight is working, but the coordinates are not working. Location is center. Okay. Center, right. But why is this not working? Location equal to center. This should work, but this is not somehow. Okay, let me just see x-axis set low. Instead of that, let me just try to see x-axis uh, set label coordinates. Let me try to keep it at say 5 0. I'm just trying arbitrarily. Okay, this needs to be removed. Okay, removed. Where is the label? 50. Is there any label anywhere? Set label coordinates to ax x-axis. Set label coordinates to be 50. Where is 50? 50 is on the axis and 0 is at the y. Okay. Uh, 0.5. If I try, what will happen? No, the setting level is not actually working somehow. I'm just trying once again. X-axis label. Okay, let me just copy and paste something to see if it's related to some typing error. I'm just trying that. Where is the x coordinates now? It is at the position zero point 0.9 minus 1. Okay, it seems to be working. Anyway, let us just try once again. Let me just push it upwards at to position 1. Position 1, it's working. 0. Now it's up to 6. So let me take this is what exactly? This is 6, right? 6 and so x is 6, x position is 6, and the other position is 0.1. But where is 0.1? 0.1 is much above. So minus 1.0. Minus 1.1. Minus 1.1 is not there. Minus 0.9. I'm trying, I'm just experimenting to see if it's working. No, even this is not working. So what about uh, 5 uh, minus 0.75? Well, that doesn't seem to work somehow. So what was the thing that I pasted? 0.9. 0.9. Oh, but why is it happening like that? 0.9. Where is it going exactly? I think it's a relative position. Okay, we try to see location of x-axis label position. Bottom left
Sir,
corner. Ah, okay. Now, okay, yeah, I think I understood somehow. So,
sir,
yeah,
sir, here like TLT dot subplots, instead of subplots, if we write only plots, TLT dot plots.
I don't exactly know. Okay, you want to see just plot?
Yes.
No, I think this
Uh,
is. See, I think the basic thing is that here the position 0 0 is taken to be okay. The position 0 0 is taken to be in the coordinate system. It's taken to be the left bottom corner. So if this is 0 0, suppose that I'm keeping. Uh, See, this total is just one, right? The graph is just okay. Let us try to increase the size of this. So from where to where it's going up to one on the top and up to 6 here it's going. But instead of taking it up to 6, let me just try to use something like so that we can easily understand. Now, minus 2, not 2 pi, just take it to be pi, and take it to be just equal to uh, or pi by 2 here. Maybe even pi by 2 minus pi by 2, 2 pi by 2. I'm just trying. I'm just experimenting with these things. Okay. So suppose that if I change like that, now the position is like this, minus 1.5. Now, if this is 0, 0, what happens is that the total height is just 1. Okay, suppose that I put, to understand clearly, suppose that I put y label at 1, sorry, at x0, and this at 1.1, suppose, or x to be at 0.1, and this to be 0.9. I'm putting it, I'm putting the y label to be this. Just trying to change it. Y label to be this. Y prime. So you can see that now this is working, right? See, y is appearing here somehow here. So the logic here is that for computing the coordinates in this axis ax, it's using the top left bottom. Okay, top left bottom. This particular point to be 0, 0. From there it's computing. So whatever we are seeing on the axis is not exactly the position that's appearing here. Okay, that's a confusion. See, the 0.1 here, the 0.1 here is not exactly the 0.1 on this axis. On this axis, it is shown something to be minus 1.5, but not at minus 1.5. This y is kept. This y is kept at the point 0.1, 0.9, where this, even though the axis is labeled like this, the bottom left is considered to be 0, 0. Got it? But somehow this location right, location left is not working. I don't know why it's not like that. Why it's like that? That command also should have worked, but somehow it's not appearing. Somehow it's not working. There must be something that I'm missing. I don't exactly know what I'm exactly missing, or maybe I can. I'll just try once again. I'll just try once again to do something extra. So let us try axis, y-axis, and set. I don't know whether exactly this is the correct thing I'm doing. Text position to, okay, this is text position essentially means that keep this what you call y markings on the left or y markings on the right. If I keep it to the right, what will happen is the position is moved to the right. That's it. The same way we can keep, that is not what we want. This to be maybe top, it's going to the top. Of course, we can turn off the complete axis. PLT dot. This is quite possible. Remember that these commands are completely working. Okay, let me just update the Google document with this. The positioning is working quite fine now. The positioning is working, but we are not able to keep the label to the right of y-axis, that right of x-axis which we actually wanted, and just above the y-axis, not to the right or left of the y-axis, but above the y-axis is not working as of now. Okay, let me just try once again. One more attempt, the final attempt to see if it's working. But location top seems to be working here, but somehow I am not getting that successfully. So by plot axis label on right, that's what we wanted. Y axis label on okay, let me just try. This is text position exactly like that. Maybe the label position also we can change. But that is what we tried, right? Okay. Anyway, once again, set y label, or already it's in the y axis, so y label is not necessary. Set label position and turning off the other things so that it won't affect. Oh no, top. Okay, this is accepting only left or right. So y label position is not exactly that thing. Maybe there is some other way. I don't exactly. I'm unable to exactly locate what exactly this is. So I can try to find out, but I'm not very sure whether, because location is equal to right is what the documentation actually says, but this command. But this doesn't seem to actually give the desired result somehow. I don't know whether I'm missing something. I can just try to update it. Okay. Maybe I have updated the Google document. Just 1 second. Feedback link. Let me copy the feedback link. Okay, and with this, probably I will stop the main discussion today, because we wanted to actually start something related to integration differentiation, which we could not, because we spent a lot of time on numeric Python where piecewise function and related stuff. We will start the matplotlib integration differentiation kind of techniques, and we will try to find out. We will try to do some maximum minima problems also related to that using this and we will try to plot also something related to those things in tomorrow's session at 6 o'clock. If there are if you want to ask something, if you have any clarifications required, I can try to answer. I'm stopping the lecture with this. I can try to clarify if there is anything required. Thank you very much for your patient listening. Questions, if any, please.
In class. Thank you all. We can meet tomorrow. Thank you.
At 6 o'clock, right?
Sir,
Yeah,
sir,
please.
will it work if we write the set y label or x label after the plot function?
Sorry, I don't understand. Sorry, can you please repeat?
Sir, the set y label or x label command,
Yeah.
will it work if we write it after the plot function?
No, no. After the plotting, what happens is that the plot function is used for plotting. After setting all the parameters, we are plotting. After plotting, once you use the plot function, we have completed the plotting. Only that showing is left. Okay, the plotting is now completely over. Once you use the plot command, the plotting is over. After that, you cannot do anything. Only the show will work afterwards.
I have just googled since it is not working. It shows that the plot function comes first, and after it comes the set x label and y label.
Okay, let us. I can just try to do that once again. Okay, let me try. 1 second. So you wanted to change the location of y level, right?
Yes, x or y.
Okay, let me try once. Just 1 second.
Okay, thank you, sir. Thank you, sir.
Sorry,
So we can conclude today's session, sir. Thank you.
just 1 second. Sorry. Okay, that's not working. Even that's not working.
Okay.
I think I can find out. I can find out an answer, and I can update you tomorrow. Okay.
Okay, sir. Thank
Okay.
you.
Thank you very much. Thank you all.